All right, hi everybody. Getting right into this because I want to try to make this video as short for you as possible. Solving systems of inequalities. And I think it should go without saying that we're talking about linear inequalities because everything we've been doing so far is about straight line data. We will change that in a little while, but not for right now. Okay, first, vocabulary. A system of linear inequalities is two or more linear inequalities that we consider at the same time. Okay, just like a system of linear equations, except now we have inequalities. Remember, the difference between an inequality and an equation is this difference right here. For an inequality, or for a linear equation, we'd have this kind of data right here on the left. That's an equation. For an inequality, we might have something like this, where we have to shade all of one side of a line because everything on one side of this line is a solution. Okay, so just to remind you of what linear inequality looks like. So a system is when we talk about two or more of them at the same time. The solution to a system of linear inequalities is the intersection of the half planes formed by each linear inequality. I know I lost somebody with that word right there. So let's just talk about that for a second. Half planes, what I mean by that is this thing right here. This, now let me change my color. This half plane, because the boundary line of our equation or our inequality, it separates the plane into two half planes. One half plane is all the solutions. The other half plane is no solutions. Okay, so the solution of a system of linear inequalities is the intersection of the half planes formed by each linear inequality, or of the two shaded regions. So what we're looking for is when we have a system of inequalities, we're going to have two shaded regions, and the two shaded regions where they overlap is going to be our solution. It'll be very clear, I think, once we do a couple of examples. The most direct way to find a solution to a system of linear inequalities is simply to graph the equations on the same coordinate plane and find the region of intersection, find out where they intersect. Really, we're not going to talk about substitution or elimination with systems of linear inequalities. We're just going to be graphing them. All right, so without further ado, let's talk about graphing them. First, step one, we want to graph the boundary line of each equation. And I want you to remember that we use a dashed line for less than and greater than. We use a solid line for less than or equal to and greater than or equal to. Step two, we want to shade the half plane for each inequality. We talked about a couple of ways to figure out which side to shade. You can always use a test point or think about if y is greater than or less than. Okay. Step three, identify the intersection of the half planes, and this is going to be the solution to the system of linear inequalities. Without further ado, let's actually do an example. So we want to solve the following system of linear inequalities. Okay, we've got this first equation in red, y is less than or equal to -1/2 x plus 3. And then the second equation in black, y is less than 1/4 x. Notice this less than or equal to tells us we're going to have a solid line, and what do you know? Our red line is solid. This less than tells us we're going to have a dashed line. What do you know? This black line is a dashed line. So far, so good. That was step one. We have to graph those boundary lines. Step two, we figure out which part of each one of these gets shaded, which half plane gets shaded. So I refer you to look at this y is less than or equal to. That means I'm going to shade below, because less than, below the red line. So notice I shade all of that in yellow. Okay, all of that in there that's shaded in yellow, that was the solution to this one right here. Okay, the second one, the black line. Notice, once again, y is less than, so we say below, and we're talking about below this black line. That's everything in here. And I know some of you have realized this because you know about art, or because you know about colors in general, or because you've played with Ziploc bags before. But we have we have yellow and blue make green. So notice my first solution was all of this, which I did in yellow. My second solution was all of this, which I did in green, which I did in blue. And the intersection is where they turned green. So it's all of this, but not any of this, and not any of this. Okay, so that's our solution. Our solution is just this area right here, and clearly it goes on that way forever, and that way forever, and that way forever. Okay, great. So that is a system of linear inequalities. It has a lot of different solutions. One solution would be the point 3, 0. Another would be the point 4, -1. Another would be the point -3, -2. Okay, those are all solutions. Nothing in here would be a solution. Nothing in here would be a solution. Nothing up here would be a solution. Okay, let's go on. So we have, and what we did here in this third step was after we had graphed everything, we just erased the stuff that I had filled in here and the stuff that I had filled in here. So it makes it very obvious that our solution is this part right here. Let's do a couple of examples. Example number 1, solve the following system of linear inequalities. Well, first thing I need to do with my red, first thing I'm going to do, oops, I guess I'm not going to do that. What I'm going to do is I'm going to move that over so that I can have some more room to write, because I write pretty big on this. First thing we have to do with our red equation, I have to solve for y. 2x plus y is greater than or equal to -4. So I subtract 2x from both sides, subtract 2x from both sides. I have y is greater than or equal to -2x. So what I'm going to try to graph right now is really the equation y equals -2x. And I figure out what kind of line I need. Well, I need a solid line because this is y is greater than or equal to. Okay, great. So once I do that, all I have to do is graph my line. Let me grab my red pen again. I know my y-intercept is going to be, it was -2x, so that's really -2x plus 0. My y-intercept is right at 0. And my slope is going to be -2. So I go down 2 over 1, up 2 left 1, and that's what my line looks like. For the next one, I have to solve that for y as well. I start with x minus 2y is less than 4. So subtract x, subtract x. I have -2y is less than -x plus 4. And then I have to solve for y still, so divide by -2, divide by -2, divide by -2. I get that y is greater than, do not forget that my sign flips when I multiply or divide by a negative, so y is greater than, negative divided by a negative gives me a positive, so x over 2, and then positive divided by a negative just gives me a negative, so 4 over 2 is just -2. So y is greater than 1/2 x minus 2. So my slope is 1/2, my y-intercept is -2, and I'm going to go ahead and graph that one. Y-intercept of -2, I go up 1 over 2, up 1 over 2, down 1 left 2, down 1 left 2. That's what you should get. And just to clean it up a little bit, I will go ahead and erase everything, and you should get something that looks relatively like what we just got, except that the red line is not showing up exactly the way it's supposed to. Never mind. Oh, the reason it's not showing up the way it's supposed to, sorry about that, was because I had the graph off just a little bit. So nevertheless, this is what we should get. I'll clear all of my ink right now. And this is the way our line should look. So step 1 is done. Next, what I'm going to do is I am going to shade in the correct parts of it. So the first one, I got y is, Let's do that real quick one more time. I should not have erased that, I guess. Okay, no, there it is. The first one, the red one, y is greater than, so y is going to be above, we're going to shade above. The next one, y is greater than, once again, we're going to shade above. So both of these we're going to shade above what we had, above the boundary lines. So if I delete those, notice I shade above each of them. I shade for this dotted line here, okay, that dotted black line, I shade above it, which is what we're doing in blue. Okay. Okay, let me clear that. And the second one, this solid line, the black line here, I shade above it, which is right over here. So these are both shaded right here, so you need to draw that in on yours. And then finally, I figure out what was the overlap between those. Overlap looks like this. I forget about this part right here. I forget about this part right here, and certainly nothing in here was ever filled out. So all I am considering is this part right here. So we erase everything that was in here, we erase everything that was in there, and all I want shaded is this part that's in green, this part right over here. Okay? And that's all there is to it. Here's another example. Solve the following system of linear inequalities. I'm going to move this over, and I'm going to solve first my red inequality and then my black one. So 4x plus 2y less than or equal to 8. Solve for y. So first subtract 4x, subtract 4x. Then I have 2y less than or equal to negative 4x plus 8. Divide by 2, divide by 2, divide by 2. I am left with y is less than or equal to, well, negative 4 over 2 is negative 2x. And then 8 divided by 2 is 4. So my new inequality is y is less than or equal to negative 2x plus 4. I next do my the black equation, 4x plus 2y greater than or equal to negative 8. Subtract 4x, subtract 4x, 2y greater than or equal to negative 4x minus 8. Divide by 2, divide by 2, divide by 2. Y is greater than or equal to negative 2x minus 4. Okay, and what we should have when we graph these, for the equation in red, my y-intercept is 4, my slope is negative 2. For my equation in black, my y-intercept is negative 4, my slope is still negative 2. So we should have parallel lines. They have the same slope. Let's see what happens. This is what it should look like. Okay, and we do indeed have parallel slopes, exactly like this. For step 2, what we're going to need to do is figure out which part to shade. And the way we do that is we look at what this sign is. This sign right here, y is less than or equal to in red. So I know I will be shading below the red line. For the black one, y is greater than or equal to, I know I'll be shading above the black line. So you should wind up with something like this, where I shade above my first line, everything right here. So I'm shading above the first line, and then I need to shade below the second line. Everything below this line right here, okay? And then we are going to erase everything that is not an overlap. So you should wind up with something like this for step 3. Everything that's not an overlap was just this, or everything that is an overlap is just this area in between the two lines. So that is your solution, anything that is in between those two lines. Okay, let's do one more. I want to solve the following system of linear inequalities. Y is less than or equal to 3, x is greater than 1. Uh-oh, special cases, I can't, I know some of you are probably saying, I have no idea what to do. Well, let's just think for a second. Y is y is equal to a number is just a horizontal line. So this will be horizontal. And x is equal to a number is a vertical line, so that will be vertical. And so let's just graph those real quick. That will be, the horizontal line will be at y equals 3, so it'll look something like that. The vertical line will be at x equals 1. It'll look something like this. And let's see what happens when I erase, or when I clear off my graph and see what's below it. Indeed, we do get something exactly like what I just said. For the next step, we need to figure out which side to shade. Well, that just is a matter of looking at our signs, okay? Y is less than or equal to, I shade below. X is greater than, I shade above, or to the right of. For X, there is no above or below because it's a vertical line. So when I say X is greater than, it means I shade to the bigger side, the right side, okay? And this gives us a chance to talk about the one thing that you should remember, I think, is that when you have X is less than or equal to, or anything that is equal to, that bar right there, that tells us we're going to be using a solid line, like so. When we have no equal to, just greater than or less than, that tells us we're using a dashed line. And the reason we do that again is because any points on that line itself are not going to be solutions. Any points on this line itself will be solutions. Okay, so now that we have figured out which side to shade, we go ahead and shade it. And we get that everything above, or everything to the right of the black shaded line, or the black dotted line rather, is going to be a solution. And everything below the red solid line is going to be a solution. And finally, our step 3 is to erase the overlap. And we just get anything in this lower right quadrant is going to be our solutions. So everything right in here. Okay, next, I want you to choose the graph below that displays the solution to the following system of linear inequalities. Okay, we have y is less than, or y is greater than or equal to negative 2x plus 1. So I know one of my lines has to have a y-intercept of 1, and it has to have a slope of negative 2. So which one of these has a y-intercept of 1, slope of negative 2? And, oh, one other thing, we have to look at what kind of line we get. We should have a solid line because it can equal. So we need a solid line, and it looks like we cannot have that one. Okay, this is a no-no because we want this line right here with a y-intercept of 1 and a slope of negative 2. We want this line to be solid. So C is automatically out. For the next one, we want y is less than x plus 2. So my slope is going to be 1 because nothing's written there, so that means the coefficient is 1. My slope will be 1 and my y-intercept will be 2. Well, I can't rule anything out there because if you look, these lines both have a slope of 1 and a y-intercept of 2. So we still haven't ruled anything out. It could be A or B. So what's the difference between A or B? Well, it's just a matter of where the shading is. The shading is there for A. It is there for B. Well, let's figure out which one we should have. We want to, let me shade this first part in red. Actually, I'll do it with my, I'm going to call this the red equation. Y is greater than or equal to means I'm going to draw above the line negative 2x plus 1. So it's going to be everything above this line right here and everything above that line right there. For the next one, I'll do it in green. Y is less than means I'm going to do everything below my other line. So everything below that line right there, everything below that line right there. And then what I'm going to do is I'm going to erase my things that do not overlap. So I erase that part. I erase that part. And what do you notice? For this one, this graph right here for B, my overlap, which is this area right here, is the same as their overlap. So the B was the correct choice here. Okay, let's move on. I want to choose the graph below that displays the solution to the following system of linear inequalities. X is greater than or equal to 2. So I need a vertical line at x equals 2, and it has to be solid. Well, vertical line, solid, x equals 2, looks good. Vertical line, not solid, not x equals 2. I know it's not that one. Vertical line, solid, at x equals 2. So it's going to be either A or C. I know B is not a possibility. Let's look at my next one. Y is less than 5. So I need a horizontal line at y equals 5, and it needs to be dotted. Well, there's one there. There's one there. They're both the same, so again, I can't rule anything out. So let's just figure out this next part. Where should they be shaded? For this one here, x is greater than. It needs to be to the right of the red line. So to the right of my red line, to the right of my red line, everything there. And then for the next part, y is less than 5. With green, I need to be below y equals 5. Below y equals 5. And then finally, I'm going to erase my overlap. Well, I erase my overlap here, or I erase my non-overlap there and there. Well, not sure what's going on there. And I erase my non-overlap there and there. And what do you know? It's got to be C, because look what's left. Over here, my overlap and their overlap is the same. So C is the correct choice there. Okay, this next one, they give us two equations, but they don't tell us what the slope-intercept form is. So I have to figure these out myself. So I am going to, there we go. I'm going to have to solve these into slope-intercept form. And so I'm going to add 5x to both sides, add 5x, add 5x. I get that y is greater than 5x minus 2. That's my red equation. In green, I need to solve that one as well, so I'm going to subtract 4x from both sides. This actually ends up being pretty easy. Y is less than negative 4x plus 1. And those are my two equations. Now I need to figure out which one is which, and which of these graphs can I eliminate. Let's look at the first one first. My slope should be 5. My y-intercept should be negative 2. Well, it looks like we're talking about the blue line there. Here's a y-intercept of negative 2, and it looks like it's got a slope, a very steep slope, so that's probably about 5. And what kind of line does it need to be? It needs to be a dotted line. So the first two are okay. A and B are okay, this one and this one. But notice C has a solid line, so it can clearly not be that. I'm going to cross out C. I know it's not C. Now I'm going to look at my next equation. Y is less than negative 4x plus 1. Well, it has to have a y-intercept of 1. That's my red line. They both have a y-intercept of 1. They both look to have about the same slope. So again, I can't cross anything out for A or B. But what I can do is talk about my overlaps finally. I'm going to highlight the red line. The red is y is greater than 5x minus 2. So it has to be above the blue line, because, sorry, this right here, my top equation is actually my blue lines. So I am going to highlight above the blue line for both of them. Okay, so it should look like that and like that. And then on my green line, y is less than. I need to be below my other line, which is the red one. I need to be below there and below the red line. And now I'm going to erase any non-overlap. There's non-overlap here, and there's non-overlap here. And so it looks like that's probably going to be A. Let's see what happens when I erase my non-overlap there on B. Erase it there, and I just happen to erase the part that they told me they wanted for B. So it's not B, the answer is A. Okay, the next one I'm going to leave for you to do. And we move on to number 5. Choose all of the linear inequalities that make up the following system of linear inequalities. So I've got these two lines here. My first line, this dotted line right here, I look at my slope, I look at my y-intercept. My y-intercept is going to be 3. So any of these have a y-intercept of 3? Well, it's going to be one of these two. I'm going to need to solve those to see if those are in the right form. That's going to be annoying, but it won't be hard. Let's go ahead. 3x plus 4y greater than 12 minus 3x minus 3x. 4y is greater than negative 3x plus 12. Divide by 4, divide by 4, divide by 4. I get that y is greater than negative 3/4 x plus 3. Well, that one's looking promising. Let's do the other one. So this one was in red. I'll do the other one in green. 3x plus 4y less than 12. It's actually the exact same thing. The only difference is this sign right here. So my answer will be the same, just with a different sign. Y is less than negative 3/4 x plus 3. So which one could this be? This is going to be my black line here, because that's the one with the y-intercept of 3, and it's going down 3 for every 4 it goes over, so the slope is negative 3/4. Now, they shade, notice, for this blue line, they shade everything below the line. So which one is that going to correspond to, green or red? Which one would be below? Well, that would be green right here. Y is less than, yada, yada, yada. The less than tells us we shade below, so I know my answer D is going to be one of them, not C. And now I just need to figure out what this other red line is. This line right here. Well, that's at negative 2. Y is greater than or equal to negative 2. Y is less than or equal to 2. It cannot be 2 because it's at negative 2. And it has to be a solid line and shaded above. That's going to be A. So I have figured out that my two equations that are graphed above are A and D. Next, a different kind of question you might be asked. Which point is in the solution set for the system of inequalities shown in the accompanying diagram? What that's asking is which point is somewhere in here. Here's the solution set. All of the solutions are in this overlap right here. Which of these points is there? Well, let's try them one at a time. 0, 4. Start off 0, I go up 4. Right there, that does not look like it's there, like that's a valid one, because notice this line right here is dashed. So that is not going to be a solution. What about B? 2, 4. Over 2, up 4, that's right over here, definitely not. What about C? Negative 4, 1. I go left 4, up 1. I found a winner, because that's right here, and that's going to be a solution. And let's just check the other one. 4, 1. I go right 4, up 1. That's going to give me something right about here. Not going to be a solution. So my answer is going to be C. And finally, another type of question you might see. Which ordered pair is in the solution set of the following system of linear inequalities? They give us a whole bunch of solutions. And they're asking us which one of these is a solution to this system of linear inequalities. Notice they give us no graph. Not a problem, though, because it is really just this simple. I'm going to, one at a time, take these points and plug them into each equation to see if they give me true statements. I'm going to do this with my magic pen so that it will erase. I'm going to put 0, 3 into this first equation. 3 is less than 2 times 0 plus 2, which means 3 is less than 0 plus 2. Well, what that is saying is 3 is less than 2. Already a false statement. I don't need to check the other equation. I know that this cannot be a solution, and I move on to the next one. Okay, next, 2 and 0. 0 is less than 2 times 2 plus 2. What that is saying, 0 is less than 4 plus 2, or 0 is less than 6. This is a true statement, so I do need to check the other one. 0 is greater than or equal to negative 2 minus 1. This says 0 is greater than or equal to negative 3, also a true statement, so this is a solution. And I go to the next one. So really, to sum up right now, what we're doing, when we plug these points into both equations, or both inequalities rather, we need to make sure that we get two true statements. Okay, let's move on. Negative 1 comma 0. 0 is less than 2 times negative 1 plus 2. Well, is that true? This is saying 0 is less than negative 2 plus 2, or 0 is less than 0. 0 is not less than 0. It is equal to 0, so that can't be. And I know that C is not a solution either. And I've got just one more to check. Okay, negative 1 comma negative 4. Negative 1 is less than 2 times negative 4 plus 2. That's saying negative 1 is less than negative 8 plus 2. That's saying negative 1 is less than negative 6. Is negative 1 less than negative 6? It is not. It is closer to 0, so that makes it a bigger number. That's not true. So we must have D also not true. The answer is just going to be B. That is all, folks. I wish you a wonderful rest of your day, and I hope that we get lots of good practice in tomorrow.